Hi, this is Pratik and welcome to Code Verify. In this video lesson, we're going to learn about implementing stack using linked list. Now, question arises that since we have already implemented stack using Python list, then why are we interested in implementing stack using linked list? And reason behind is that if we implement stack using an array, then you have to specifically mention the size of the array. And as you keep on pushing elements inside this array, since the size is limited, so after you reach the upper limit of the array, you cannot push more elements because that's the size of the array, it's fixed. But in case of Python, since we are using Python list, it is a kind of dynamic array which keeps on increasing as soon as you hit the limit. So in Python, it's not a problem. But for other languages, if the array size is static, it may lead into problem because you cannot push after a certain limit. So that's where this idea of implementing stack using linked list emerged. Now, as I've already told you that there are two basic operations in stacks, that is, first is push and the other was pop. And one of the most important point that one should keep in mind that push and pop has to occur at the same side. Now, there are a couple of resources in the internet where it's written that stack is last in first out or first in last out. This is kind of a bit confusing and I pretty much don't like to remember this, although I remember this, but I recommend not remember this. The only thing you need to remember is that push and pop occur from the same side. It doesn't matter whether it's occurring from the right side or left side, but the only thing that matters is that they have to occur from the same side. Now, if we take this linked list as example, then there are two sides, the right side, the left side, and right side. So you have two choices, like you can either push your newly created node in the left side, or you can append it at the extreme end of this linked list. If you try to push your newly created node at the end of the linked list, then it's kind of you have to traverse from the head and up till the end of the linked list. So it's gonna increase the time complexity of the code. And also, since you are willing to push the node at the end of the linked list, which means you have to also pop the node from the end. So again, for popping, you have to traverse throughout the linked list up till you reach the end, and then only can pop. So it's kind of increase the time complexity of the problem. So what I would prefer is that you should push and pop from the front of the linked list, and that would be really, really fast. Now, suppose that you created a new node having data of 4, and you want to push this newly created node at the front of the linked list. To do this, you have to do two important operations. So first, you have to link the next part of 4 to point to this node. And to do this, you have to take the reference of this node, which is already present in the head. So you have to write something like new node.next is equal to self.head. So you take the reference which is present in the head and you put that in the new node's next part. And after this, the second operation that you got to do is to make the head point to this newly created node. So you're going to write self.head is equals to new node, which means now you make this connection. And now I can say that you have successfully pushed this newly created node at the front of the linked list. So we are done with the push operation, and now the second operation that we got to do is pop operation. So the story was saying that you have to push and pop from the same side, which means you also have to pop from the front of the linked list. Now, if you pop from the front of the linked list, then one thing is for sure is that you have to again change the reference of head to point to this node. So that's how you actually delete the node from the front of the linked list. You simply shift this reference to point to this node. So here you take whatever is present in self.head.next and that you put it in self.head, which means now the connection changes and the head now points to this node. And when this code runs, since this node is not being referenced by any other node, which means during the runtime, this node will automatically get flushed out from the memory. So this is how push and pop operations are done using this linked list. So this is the basically how you can implement stack by using linked list. So now look at the implementation part. So first I am gonna define a class node, and this class is gonna have a constructor which will be responsible for creating the basic structure of the node. So here I build the constructor, and in this constructor I am going to define self.data as the node data, and this node data is actually the data that I want to insert into the data part of the newly created node, and I'm going to make the next part of the newly created node as none. And now I'm going to define a class called stack, and this class will be responsible for building the overall stack. And now again I am going to define a constructor, and in this constructor it will reference the head as none, because remember that during the starting of the linked list, there's no nodes present. All right, so since the stack is empty, you're going to start from the beginning and you have to push node by node. So initially, since there is no node, which means the head is actually none. And when you make an object of the class stack in the main, this constructor will be called automatically and the head will be initialized to none. Now remember that you got to perform two operations. The first is push and the other is pop. So I am going to define a push function which will be responsible for pushing a newly created node at the front of the linked list, and it's going to take as parameter as the data that I want to push inside the newly created node. And now in this push function, I'm going to make use of the constructor that is defined in the class node, because that's how you're going to build a newly created node and then you got to push it. So in this push function, I am going to make an object of the class node, and I'm going to pass data of the node that I want to put in, and I'm going to call that constructor as a new node. Now after this, I got to take the reference from whatever is stored in self.head, and I have to put that in new nodes next. And after done that, we are going to change the reference of the head to point to the newly created node. So we have successfully pushed the newly created node at the front of the linked list. So now the second operation was pop. So I am going to define a function called pop. And one thing you got to remember that since you're popping, so first you have to check whether something is present in the stack or not. So if the stack is already empty, you just cannot pop out from the stack. So in that case, I'm going to check if self.head is none. So if self.head is none, which means the stack is empty and there are no nodes to be popped out from the linked list. And in that case, I'm going to print, sorry, the stack is empty. Else, if the stack is not empty and some nodes are present, then I am simply going to write that print the node that I want to pop out. So the node that I want to pop is having the data self.header data, because that's the data which is present at the front of the linked list. And now, having done that, I am going to shift the reference of the head to point to self.head.next, which means we are dereferencing the first node that is present at the front of the linked list. And once it gets dereferenced, then during the runtime code, that memory will automatically get flushed out. Now, if you want, you can also find the peak of the linked list. So I'm going to define a function called peak that is going to look at the stack and it's going to find what is at the top of the stack. So here I remove that since we are pushing and popping from the left, so the top is the left, that is the front of the linked list, and the peak would be self.head.data, and I'm going to print it. Now I'll build the stack, but I'm also interested in finding out what does the actual stack look like once I'm finally done with building the stack. So I'm going to define a function called print stack, and this is going to display as the stack that we have finally inputted into this code. Now since we are in the stack during using a linked list, so you have to traverse from the front of the linked list up till the end of the linked list. So to traverse, I am going to define a new variable called L, and that's going to refer to self.head. And using this L, we're going to move forward the linked list. And to traverse, you have to define a while loop. And inside this while loop, I am going to print the data, and then I'm going to shift my L to point to the next node. And after doing this, our L will move forward one step at a time, and it's going to print the data of each and every node up till it reaches the end of the linked list. So when it reaches the end of the linked list, we have to break this while loop. So for that purpose, I am going to add a few lines here. So I'm going to say if L is none, simply break the while loop. So when the L finally reaches up till the end of the linked list, then the L will finally become a none, and in that case you have to break this while loop. So now to build the stack, first I am going to make an object of the class stack, and this will automatically run the constructor that is present in the class stack, and it's going to initialize the head to none. All right, so now I am gonna push 3 nodes into this empty stack, and the first node will contain data of 1, and the second with 2, and third with 3. Now I am gonna print out the stack formed here to show you how the overall structure looks like. So I'm gonna save this, and then I am gonna run it. All right, so see here it started with 1, and it put the data 2 inside the nitty-gritty node, and the third node that was pushed in was the node which it has 3. But this is working fine. So after this, I am gonna pop out from this stack. I will print the result in a new line, so I'm gonna add a new line there, and I am gonna then call the pop function by using the object that I created here. This pop operation is actually going to pop from the stack, and after the popping has been finished, I am also again interested in printing the stack. So I'm going to save this, and I am going to run this to see what it looks like now. So here it is. So first, the initial stack was this, having nodes with data 1 to 3, and then 3 was popped because the push is performed at the front of the linked list, which means the popping has also to be done from the front of the linked list. So after popping 3, the remaining stack contains nodes having data of 2 and 1. So this is how basically you implement stack using a linked list, and I hope that you understood this. Like and share this video, subscribe to the channel, and thanks for watching.